yeah, I'm Serena, and I'm very glad to be here with you today. So I want to talk about the provisioning of a Plone server using Ansible and Molecule. I will talk about a bit of introduction on Ansible, on Molecule, and then how to apply those theoretical concepts to practical tasks like provisioning a Plone server. For those of you that don't know what Ansible is, it is a tool that I use now almost daily, and it helps in doing system administrator tasks, basically. So it allows to write recipes that help us in automating the repetitive tasks like server provisioning and software deployment. It has gained a lot of popularity in the last few years because it is very simple to install and very simple to use. It is an agentless package. Everything is done by SSH. You don't have to install anything on your target hosts. I will refer to targets as the hosts that have to be configured. Its recipes are written in YAML, which is a language that is very dear to Python programmers because we all love indentation. And it is written in a language that is human readable. Its documentation is huge and the community is very active. In fact, we have a place called the Ansible Galaxy that contains all the roles that are developed by the community, and these roles are also evaluated. So you find a place where you can download things that are, in theory, well written if they have a lot of stars, a lot of downloads, and so on. Being so easy to use, it encourages to use it as often as possible, and so one becomes more disciplined about never logging into a server to do configuration without Ansible, or like never logging into a server manually, let's say. So why Ansible today at the Plone Conf? Well, there is an Ansible role here that is for provisioning a Plone instance. A Plone in production is actually quite hard to install because it has a lot of moving parts which I honestly don't know anything about because I've never installed Plone before of this week. And it has some server and client components and stuff that controls the network connections and so on. As I said, I don't know this project, but I like to jump into things that I don't know using Ansible when possible, because there are people out there that have written recipes for the community. And so let's pretend that I had to install Plone on some server. What should I do, and what would be my test strategy? Now a bit of theory. Ansible is a Python package, so it has to be managed using the Python tools, which are the virtual env and the Python package manager, that is pip. Ansible is available also on many system package managers like apt, yum, and stuff like that, but their versions there are very outdated, so please never use your operating system package manager to install Ansible. Always use virtualenv and pip. Now, let's create a virtualenv using a reasonable Python version and install the latest Ansible version available. And check that Ansible works. So for checking that Ansible works, we call an Ansible module with this syntax. minus M stands for module. I will tell Ansible which are my target hosts. It is localhost in this case, and I run the Ansible command that now I have available in this virtual env against the inventory file. And success. I have pinged my localhost, and the answer is Pong as usual. So yes, installing Ansible is that simple. Now, we will take a look at more complex structures like roles, playbooks, and stuff like that. So just for explaining myself a little better, I want to write the command that I gave to the Ansible program in a playbook, which is a YAML recipe that basically does exactly the same thing that we have just done. So I wrote in this YAML file the instruction to ping my instance, okay? And the answer is something like that. So this is the typical Ansible output. And we have pinged the localhost once again using the Ansible playbook command, if you see, instead of the plain Ansible. The plain Ansible calls one module at a time. The Ansible playbook calls a recipe that contains a lot of calls to modules. Now, let's do the things the right way from the beginning. So it is very tempting to jump into writing a huge Ansible playbook once we have installed Ansible, because it works, actually. So why bother using more complex structures if a huge YAML file contains all the things that I want to do? Well, it is an effort that is very, it is worth it, because roles are the way that the community shares their code. So people expect to find files in some places, and the Ansible playbook command expects to find things in certain places when using roles. So roles are actually just a directory structure that correspond to include directives. Okay, so you write in a directory what the Ansible playbook command expects to find. Okay? And it helps not only documenting and doing the things the right way, but also to write more complex recipes, because maintaining a bunch of small files is easier than maintaining one very large playbook. And yeah, it makes the life easier for others and for us as well. Roles can be created by using the Ansible Galaxy init command. So once you install Ansible, actually you find a lot of Ansible-related commands. Ansible, Ansible Playbook, and Ansible Galaxy are those three that we are seeing today. But instead of using Ansible Galaxy, I want to use another thing. I want to use Molecule. Molecule is a project that is designed to help in the development and testing of Ansible roles. Molecule was adopted by the Ansible by Red Hat project at the end of the last year, so it has become a standard in producing Ansible roles of high quality. And it basically is a wrapper around Ansible calls. So it supports every provider that Ansible supports. If Ansible supports Docker, Molecule supports Docker. If Ansible supports EC2, Molecule supports EC2, and so on. Okay? If Ansible can use it, Molecule can test it. So we will create a role using molecule which wraps the Ansible Galaxy command for us and does also other very interesting things. For installing Molecule, we do the things the usual way because it is a Python package again. So in a proper virtual env, you install a certain version of Molecule and also dependency, test infra, with pip. Okay? And now we create a role using the molecule init role command. Now the name of the role is given to the -r flag, and the type of driver that we want to use is identified here. I was in this path, the test directory, so now I have an example directory filled with all the directories that the Ansible roles have to have, plus another other interesting things. So inside this role, we will find out that there is a molecule directory, which usually, well, which you not usually, but always you don't find when you use the Ansible Galaxy command. Okay. This molecule directory contains what is called a test scenario. For those of you that are not familiar with the Ansible role scaffold, just remember that the important things must be in the task directory. Okay, here you have to write the start of your role journey, let's say your first YAML recipe. Now, in Ansible, everything starts from the task main.yaml file. You have to call this file exactly like this. And Molecule has created an empty file, of course. Now, I fill it with a very simple command to run some code. Okay, I want to say hello to myself, and don't mind about the changed when syntax. It is done for idempotency purposes, but I don't know if I have to dive into this. Now, Molecule has created a playbook for us that stays in the default scenario. This playbook is calling the example role. In the example role, there is a task, there is a main.yaml file in the task directory, so everything works, and I can use the Ansible playbook command against the playbook created by Molecule, and this runs my role. And it is very nice, and it says hello. So we have seen how to install Ansible the right way, Molecule the right way, and create the simplest Ansible role following the best practices. So creating a role structure plus a molecule directory. Now, what about these molecule tests? So the default scenario contains stuff for running this role in a Docker container because I've decided to run it in Docker. What is needed for running tests in Docker? Well, a Docker file that creates my container, and a molecule.yaml file, and the playbook.yaml file that calls the role that we have just seen. The molecule file tells Ansible that we have a platform to run this test, and this platform is a CentOS 7 image. So this means that this role will run in a container that is based onto the CentOS image. Okay, this file is very simple, and it represents the components that the molecule use to spin up the instance. Okay, you can have actually a lot of platforms or instances under the platform list. So you can test parts of your role onto some instances and other parts onto some others, which is very neat. The test matrix that the molecule provides is very long, and the molecule test command with the help, prints out which are all the tests that the molecule is going to run. So we have linting phases, creation of instances, idempotence test, so run your playbook twice and check that nothing has changed. Converge, which is the phase where the tasks are actually executed, and clean up, destroy, and stuff like that. Unfortunately, the linting phases are quite difficult to pass. So honestly, when I am in the development phase, I disable them, and for you, I included here how you disable the linting of the YAML code and the Ansible code. Now, the test matrix that is more interesting for me is composed by these phases, okay? We can forget about the others. So we have the lint for those that like linting, creation of the instances, converge, so run this role, idempotence, run this role twice and check for changes that don't have to happen, and destroy the instances. The default scenario is the Docker instance, and the converge phase runs the equal law in this instance. The idempotence was completed successfully because, if you remember, I said changed when false. It is a trick that you use when you use the command module in Ansible, but just bear with me. This idempotence test was okay. And then you destroy your instance, so you clean up after yourself. Now, there is a Plone, an Ansible role for provisioning Plone, or for deploying Plone onto a server. I clone this role. I follow the documentation, so there are instructions that says make and download other dependencies, and now I have a very large directory which I couldn't show you here. But just keep in mind that there are a lot of roles and a lot of playbooks that are different flavors of your provisioning options. You want a large instance, you want a small instance, and stuff like that. So personally, I want a very small instance because I want to do the things just for testing purposes and fast. So I copy the sample very small YAML file into the expected local configure.yaml. Follow the instruction on the Plone website for this. And I did, again, following the README, disabled all the components that I don't need and configured some things that are instead required. Okay? So now I am ready to use Molecule. Well, I'm not initiating a role here because I have a role. I actually have a lot of roles in the role directory. I want to inject just the Molecule directory here in order to be able to run my Plone roles in these Molecule scenarios. So instead of using the init role command, I use the init scenario command, which does exactly this thing. It injects a Molecule directory into the Plone folder of roles. Okay. I I'm using a different driver here. I tried Docker first because it is my always my first choice when I run tests, because I like how fast spinning up and down containers with Docker is. But it didn't really work because services bother Docker. And I didn't want to use strange Docker instances or strange configurations, so I switched to the EC2 option. Okay. Now, what's inside the molecule directory? There's not a Docker file because I didn't use Docker. I used EC2. So I have some playbooks that create the EC2 instances for me. Now, the molecule.yaml file looks a bit different, but not very much. You just tell molecule that its provider is EC2 instead of Docker, and you use a different code for the image keyword. And you also use another variable that is the instance type, which applies to EC2 and doesn't apply to Docker. I wanted to use a very small instance because I don't want it to be charged for my tests. And the create.yaml file, which can be compared to the Docker file that we had before. Those files are for creating the instance, basically. Is a bit more complex, and it does a lot of things. It creates the whole EC2 instance environment. So it creates the networking part with the VPC and subnets and firewall rules and stuff like that. And it creates an SSH key pair for talking to this instance. It expects, unfortunately, to find an environment variable called the EC2 region. It is a bug in Molecule, this actually. It expects to find the AWS credential somewhere, and it starts the AWS instance. This is just a little part of what this create.yaml file looks like. Now, I wanted to change the default playbook that I'm going to run with Molecule because I don't want to include the Plone role because it doesn't have the task directory directly in the level 0 of the folder, let's say. I wanted to include the playbook that includes all the roles. So I use the include word instead of the role word, and I include the playbook.yaml file prepared following the Plone instructions. And this playbook is a collection of around 13 roles, more or less, if I'm not wrong. And, well, using Ansible Molecule EC2, I can dare to say that this has become a test-driven cloud deployment. That's a lot of words. But it is also true. So running Molecule Converge instead of Molecule Test, because I don't want this instance to be destroyed right after the creation of the Plone server. I want to be able to check if I see a Plone website there. I wait around 15 minutes of Ansible output, and ta-da! I see the interface of the Plone, I think, administrator web page there on the HTTP standard port of my EC2 instance. So just maybe we can discuss later if this is enough for testing the deployment of Plone. I don't know, actually, because I've never done that before. But it was good enough for me, not knowing what I should look for, okay? Okay, then remember to destroy this instance because you just run the molecule converge command. So there is an EC2 living instance somewhere in AWS that is charging you for money. Molecule destroy, and it destroyed this instance, so it remembers what name is that. It has the SSH key pair correctly cached somewhere, and so on. As I said, the molecule test command would do the full converge idempotence, which is very interesting, destroy workflow. And for wrapping up, because I think I run out of time, yes, everything is very easy when you know how to do it. So Ansible is easy, Molecule is easy. And there are, it allows to have many pre-configured test scenarios, which is very neat. Think about that for concluding. I could have done the exact same thing without a molecule. I could have spin up an EC2 instance, write the name of the instance somewhere, and run the Plone Ansible role against this instance. But how better is that I have a directory where I have a pre-configured scenarios, one like EC2, the other Kubernetes, the other is Docker and stuff like that, and I can think about testing a complex architecture in a pre-configured way, so I don't have to bother with writing Ansible code for spinning up and down a complex network infrastructure and many machines and stuff like that. So actually, doing the things this way, I think it saves a lot of time and encourages you to do the things the right way. And yeah, thank you for your attention.